Hello and welcome. Today we're going to continue our discussion on reducing rational expressions. First, let's simplify each of the following. 19 over 19 can be reduced by 19 on both the numerator and the denominator, since 19 is a factor of both. This becomes 1 over 1, which is simply 1. Now our negative 3x and 3x can be reduced. On top, we end up with a negative 1, and on bottom, a positive 1. This leaves us with negative 1 over 1, which is simply negative 1. Third, to the right, I have the same exact thing on the top and the bottom, so I may cancel out that entire x plus 3 with the entire x plus 3 on the bottom, again leaving me with 1 over 1, which is just 1. Now down to the left, these are not exactly the same, but I can easily make them identical by simply rearranging the numerator. In the numerator, I have 5 plus x, while in the denominator, I have x plus 5. So I'm going to rewrite this on the top as positive x plus 5, which is the same thing as 5 plus x, just in a different order. And the denominator is x plus 5. Now again, just as in my previous example, I have the same exact thing in my numerator and denominator. So I may cancel out the entire numerator with the entire denominator, leaving me with just 1. In the middle, on this second row, I need to factor out my GCF of my denominator. So in the numerator, I have x plus 3, and in the denominator, when I factor out a 2, I'm left with 3 plus x. Now I need to do what I did in the previous example and rearrange my factors so that the x plus 3 matches the 3 plus x on the bottom. So what I'm going to do is leave my x plus 3 and rearrange the 3 plus x in the denominator. It's positive 3 plus x, but I can write that as positive x plus 3. Both of them are positive and remain positive. Now I can cancel out that entire factor of x plus 3 from the top, leaving me with just 1, and on the bottom, leaving me with just 1. So in the numerator, I only have 1, and in the denominator, I have 2 times 1, which is simply 2. Last, I may factor out a 5 from my numerator, leaving me with x plus 2, and in the denominator, I have 2 plus x. Now I'm going to rearrange these so that my factor in the numerator matches that 2 plus x in the denominator, or the other way around. Since I have 5 times x plus 2 in the numerator, I'm going to rearrange my denominator so that that x comes first. I have positive 2 plus x, which is the same as positive x plus 2. Now I see matching factors in the numerator and the denominator, so I may cancel out that entire factor of x plus 2, leaving me with 5 times 1 on the top and simply 1 on the bottom. 5 times 1 is 5, and on the bottom I only have a 1, so this reduces to simply 5. Now remember, anytime you are reducing, you must first factor out the GCF and then proceed to factor both your numerator and denominator completely. Now looking at this first expression, I see that I have a negative and a negative in common on my numerator. On the bottom, there are no negatives, so I'm going to go ahead and factor out this negative as my GCF. Taking out a negative 1 leaves me with a positive x plus 3. And in the denominator, I have an x plus 3. Now I see a common factor of x plus 3, so I may cross this out of my numerator, leaving me with 1, and my denominator also leaving me with 1. So in the numerator, I have negative 1 times 1, which is negative 1, and in the denominator, I just have 1, leaving me with simply a negative 1. Now to the right, I have a negative x plus 5. Now remember, that first coefficient must always be positive. Since I have a negative in front, I'm going to go ahead and factor it out. Factoring out that negative 1, I'm left with positive x minus 5, and in the denominator, I have x minus 5. Now notice that those two factors of x minus 5 match in the numerator and the denominator, so I may cross those out, leaving me with 1 in the numerator and the denominator. In the numerator, I have negative 1 times 1, which is negative 1. And in the denominator, I just have 1, which reduces down to negative 1, just as my previous example. Now looking at this last example on this slide, I notice that I have a 5 minus x in the top while I have an x minus 5 in the bottom. If you notice, these terms are exactly opposite. I have a positive 5 and a negative x on the top. But in the denominator, I have a positive x and a negative 5. So my signs have been switched on both terms. If the terms are opposite, I'm going to factor out a negative 1, just like I did in the examples above. So factoring out a negative 1 from the top causes my 5 to become a negative 5, but my x becomes a positive x. Now I'm going to just rearrange these so that these terms, 5 and x, match the order of the denominator. When I rearrange them, I end up with negative 1 times positive x minus 5. So all I did is I switched the positions of these two terms. In the denominator, I have not touched anything, so I still have x minus 5. And now I identify a common factor between the two. I see x minus 5 repeated in the numerator and the denominator, so I may cancel those out, leaving me with simply the negative 1 that's on the top. Let's go ahead and practice this a couple more times. Looking at this first example, I see I have a positive 3 with a negative x on top, while on the bottom, my x is positive while my 3 is negative. So my terms have been switched in regards to their signs. Because of this, I'm going to factor out a negative 1, causing my 3 to become negative, but my x to become positive. I'll then rearrange the terms inside these parentheses so they match the denominator, leaving me with negative 1 times, and in parentheses I bring the positive x first and the negative 3 second. In the denominator, I still have that x minus 3. Now I see an x minus 3 repeated, so I cross those out, and I'm left with negative 1. In this second example, I again see I have a positive x and a negative 5, while in the denominator I have a positive 5 and a negative x. The numerator and the denominator are identical, except that the numerator has signs which are exactly opposite of the denominator. So again, what I'm going to do is factor out a negative 1. You may do this to either the numerator or the denominator. I'll go ahead and stay with the numerator since that's what we've been doing. Factoring out a negative 1 leaves me with a negative x plus 5, and the denominator has not changed. Now, in order to make these terms match so I may cancel them, I'm going to rearrange my terms inside my parentheses and write my positive term first. So I have negative 1 and inside parentheses positive 5 minus x. In the denominator, I still have 5 minus x. Now I see matching terms in the numerator and the denominator, so I cancel these out, leaving me with just that negative 1. So you might be noticing a pattern with all of these, that if we have opposite terms, when we cancel out those factors, we have been left with negative 1 every time. This will always be the case. As long as your terms in the numerator and the denominator are opposite, then everything will reduce down to negative 1. Go ahead and pause the video and try the next two on your own by first factoring out a greatest common factor and then rearranging your terms. Go ahead and check your work. For both of these, as previously mentioned, you should have reduced all the way down to negative 1. Here on this next slide, we are going to repeat that process, except we're going to have an additional coefficient as part of our expression. So notice, although I have a 5 as part of my numerator, I have this factor of x minus 3, which is exactly opposite from my denominator of 3 minus x. So what I'm going to do is remember that these two will reduce to a negative 1. Since I have a positive x and a negative 3 on the top, and on the bottom I have a positive 3 and a negative x, these two will cancel and become a negative 1. So I cancel these out, they become a negative 1, and 5 times negative 1 is negative 5. To the right, I have a positive 2x and a negative 5, But in that second factor in the denominator, I have a positive 5 and a negative 2x. Exactly the same, except all the signs have been switched. Because of that, I may cancel out these two factors, and they become a negative 1. So 3x times negative 1 is negative 3x, and the denominator has a 2. Go ahead and pause the video and try the next two on your own. First, you should have negative 7 over 6x, and second, negative 9x over 4. We're going to continue this by just adding a few more factors into both your numerator and denominator. First, we're going to look for and reduce identical factors, and then we'll look for factors that are exact opposites like we've seen in this lesson. Identical factors will simply cross out and reduce to 1, while opposite factors will reduce to negative 1. So first, identical factors. I see a 3 plus x on the bottom and a 3 plus x on the top. Those cancel each other out completely. If you would like to write them as ones, you may. It doesn't really matter in this case. I see no more identical factors, but I do see a pair of opposite factors. In the middle, I have positive 5 minus 2x, and on the bottom, on the right, I see positive 2x minus 5. So these two cancel each other out and become a negative 1. Only one of the two becomes a negative 1, the other becomes a positive, if that helps you to multiply things out. Now on the top, I have an x plus 8 times negative 1 times 1, or simply times negative 1. And in the denominator, I have 1 times x plus 4 times 1, or that's simply x plus 4. So all I'm going to do to simplify completely is to distribute that negative 1, leaving me with negative x minus 8 all over x plus 4. We can't do anything else from here, so we leave our expression just like that. To the right, first I'm going to look for identical factors where all the terms have the same sign. X plus 2 doesn't have any identical matches. Neither does the 3 minus 4x. But this positive x plus 5 does in fact match with the positive 5 plus x. If it helps you to rearrange these, you may. Positive 5 plus x can be rewritten as positive x plus 5, which does in fact match exactly to the x plus 5 in the top. So these two cancel each other out completely. Now I look for opposite factors. X plus 2 doesn't have any opposite factors, but the 3 minus 4x does. I have a positive 3 and a negative 4x, and in the denominator I have a positive 4x and a negative 3. Both of those terms are exact opposite of the factor in the numerator. So I cancel these out and they become a negative 1. Now I multiply what's left and I'm done. I have an x plus 2 and a negative 1 in my numerator. So x plus 2 times negative 1. In the denominator, everything canceled except for my x plus 3. Now all I have left to do is distribute that negative 1, leaving me with negative 1x, or negative x minus 2, and my denominator is just x plus 3. Since there's nothing left to do, we leave our expression just like that. Go ahead and pause the video and try the next two on your own. When you are simplifying these, you need to be very careful. We cannot reduce any farther in this case because I have a negative 3x plus 1 in top with a positive 3x plus 1 in the bottom. These are not identical, nor is everything exactly opposite, so we cannot reduce them. And same thing here with our second example. On this last slide that we're going to discuss, the only thing I want to say is that when you are multiplying, you may also reduce diagonally. So here I may reduce my x minus 3's, leaving me with an x plus 2 on top and an x plus 4 on the bottom. To the right, I cross out the identical factors of 3 plus x and x plus 6 diagonally. Then on the right, since 5x minus 2 is an exact opposite with 2x minus 5, that becomes negative 1, leaving me with negative 1 times x minus 1 in the numerator and just x plus 1 in the bottom. From there, we distribute the negative 1 to simplify completely. Go ahead and try the next two on your own and enjoy the rest of your day.